Okay, so session 5, practical challenges in implementation. And our first speaker today is Dr. Rob Headrick, who will talk about mobile lung screening challenges. Dr. Headrick.
Thank you, and it's great to be here. I was given 8 minutes to talk about a journey that's taken 8 years so far to speak about the challenges that we've incurred. There's a lot more than what's been in this slide, but there's a lot of positive things too. So if you look at where we are in the current state, we now have probably 24 medical centers either with the bus delivered or in the process of implementing lung screening. We have the VA Medical Center now adopting it. We had Alberta, Canada, looking at a province-wide process. They were just down at our site. We're getting calls weekly to come down and start the process of initiating. We also have the first mini fellowship approved by our Thoracic Surgery Foundation, where we got a physician from Oshner Clinic who's going to be coming up and spending 2 weeks with us in the mobile program. And then we're going to help them set that back up in the rural southern New Orleans area. This month, we hit our 10,000th patient we screened through a mobile process, and we've got about a 70% compliance rate. It sounds easy, but here's the backstory. You have a thoracic surgeon building a mobile bus that doesn't exist with funding that's questionable, and a lot of people not necessarily supporters, but a lot of naysayers. There was no one who had built one. There was no data driving it. And you've got to build something that is literally from scratch with willing to make lots of mistakes. So the beauty of it is we've all survived. We've had great partners. Go-To Foundation has been incredibly patient and supportive of our second bus that's getting ready to be delivered again on the end of this month. We went through a pandemic. We went through sales of ownership of building the buses. We went through supply chain shortages, but I think we're on the better side of that curve with a lot more knowledge. So why did a thoracic surgeon do this? So I was frustrated 2015 with the lack of adoption of lung screening. And just like everybody else from the original meetings we had all surrounding it, with the American Cancer Society, I just go, I can't keep getting mad at the people or the process if I'm not understanding what the issue was. I narrowed it down to we had 2 issues. We had a messaging problem, meaning nobody outside of my circle knew anything about lung screening. And we had a listening problem. We weren't listening to the patients. They're not willing to spend a whole day getting a screening test that they don't really want for a process where they're currently asymptomatic. How much time were they willing to give us? Turns out the same time as this talk. It equates to the same amount of time a human will wait for a meal you need, but you don't really want. And that's will equate in the South to a McDonald's. You may wait slightly longer for a Chick-fil-A or something you perceive as higher quality, but it's not hours. So I felt like we got to get the message out. We have to execute a screening study in 5 to 7 minutes. And there's no way I can do it in the brick and mortar buildings we have. So that's what led to as we were putting lung cancer screening together, a mobile, one piece of the puzzle was I felt had to be a mobile. We had to go to the patients and make it that simple, but also create something that allowed for the messaging to take place in the education. I'll tell you, 8 years into this process is way different than year 1. Our current bus is at max capacity, over 3,000 people scanned on it per year. It's booked a year in advance. We used to have to go out and not beg, but we had to spend a lot of time getting somebody to allow us to come in and screen patients or show up in a community and have people come on board. We go to communities now, they sign themselves up. So it is an 8-year journey. It's been painful, but we're certainly way further along. So I'm gonna go through some of the issues that when people come for a site visit, they ask us what were our challenges, the same challenges they may be talking about. And first is what type of bus. Second is the most critical component of the bus turned out to be the HVAC unit, which we weren't aware of when we started the process. How we operate the bus, how do we get the results reported, and how do we get the follow-up compliance. So you can build a box truck, which is what we currently have. You can have an RV, which is what we start out with. You can have a tractor trailer. They all have different build issues, and they also have different limitations. So we started out with the quickest thing I could do. Once I had funding from some local donors to do this, I went to Cedar Falls, Iowa, where Winnebago is. We purchased the largest chassis, which is 27,000 pounds. Took an old 16 slice CT scanner that Siemens helped us make it a little bit more robust. They were concerned it wasn't going to stand the vibrations and all the road challenges. And I built it exactly like an imaging center we see in the hospital, and everything about that was wrong. A recreational vehicle could not carry the weight and sustain it. So at year 3, it was taken off the road for safety reasons. The chassis was fractured. The throughput was restrictive of coming in and out of how we go into radiology departments. But also the HVAC system, you have to maintain a certain temperature and humidity control for that CT scanner to be happy with the environment. It'll shut down if you're not in that range. Well, in Tennessee, it gets to be 100 degrees and humidity is stifling. And you're opening the door, letting people in and out. As my dad used to yell at us, shut the door, we're losing factory air. It was something you can't control with normal recreational HVAC units. So we went through probably 25 different HVAC units. And we had learned that the concept worked, but the design build was completely wrong. So we went back to it and said it needs to have a 10-year lifespan. We need to double the chassis weight, make sure that the transmission engine components are going to last. But we need to create something that can be repaired locally, wherever that bus is. So if I'm building one that exists in the country, not 10, and that builder's 5 hours away, and we have a problem, how do we fix it? How do you not shut down the program? How do you get it back and forth? So we went with diesel. We went with something that a local diesel mechanic could get through and fix for us. We wanted to minimize the cost to build it, just to ensure the success of the project. Had to navigate all of our rural terrains, and we wanted to hit that 3,000 goal that we achieved this past year. So that's the current bus. 3 years into it, has done beautiful, except now we had a diesel generator failure. Seems simple, except supply chain issues still exist. Shut the bus down for 3 weeks. We lost 300 patients in our screening process. Some of those are annuals that we have to now work back into the system. So mechanical failures of it are real. In doing so, we then take that information on the future buses, have tried to modify things that would improve that performance. From a where are we at with this kind of a build? You have to buy a chassis from Freightliner or Kenworth, got to wait for it to be built, deliver to the company, and then you're building the box piece on it. There's a better solution. The Tesla cabs are fascinating from an engineering standpoint. You can buy a cab, hook it up to a trailer. It doesn't have to be the same length as an 18-wheeler. And you can have one cab and multiple trailers, and you can build them simultaneously. So we'll go from a year or 2 or 3 build time to short few months. And you can also operate at a lower cost by doing it. What's the big elephant in the room? This is one of the examples that you've seen this week. The battery, 10,000 pounds, lithium battery, fire risks are not high, but certainly realistic. So one of the Tesla cabs driver probably fell asleep, hit a tree, caught on fire. You've got 63,000 lithium ion cells in it. Each has 6 liters of gas. You're emitting almost 400,000 liters of a toxic gas that's now a biohazard. You have to have hazmat suits, and water will not put out a lithium fire. It just cools the temperature down. So 16 hours shut down the freeway. The trailer was engulfed in the fire. So whatever we have attached to that cab is going to be ruined also. There's ways of mitigating it. I think these are problems that are easily solvable. But what I think this might do is shorten our build time, get more on the road quicker, and actually make it simpler to manage. Temperature issues, if you're in Alberta, Canada, and you're 20 below zero, how does the battery work? Diesel fuel doesn't work well there either. There's a lack of infrastructure for them, but you can go 300 to 500 miles, so it's not really necessary. You're not driving it as you're doing across country. I can tell you from a golf cart, I had the first experience of a lithium battery that said 17% charged, and then 30 seconds later it was 0, wheels locked. I was stranded in the middle of our neighborhood on the street. Everybody came out and laughed at me. You cannot push an electric motor that has 0 battery charge. I had to tuck my pride, but basically you've got to manage all those things, but easily done. From a Operating the bus, we just feel like a CDL driver needs to be there. We've gone through different models. We use a simple registrar using Epic and communicating back to the hospital, then a CT tech, but that CT tech in the future is not going to need to be there. Started with cell towers, unreliable. Actually started with dumping data at the end of the day. Radiologists hated it. Cell towers, unreliable. We went to 2 cell towers. Still works, but not the best. Starlink is going to solve that issue. Cheaper, more HIPAA compliant, safer, faster. You have to have an AI tool to process the data. You now start talking about 10,000 people you're following in repetitive scans and in this database and how the radiologists handle it. It gets complex. We currently report coronary calcium scoring with the low-dose CT from the bus. And then getting the results to the patients. You can't call them or mail them. It just doesn't work. So we went to text messaging, HIPAA compliant, incredibly inexpensive, jumped from a 30% annual compliance rate to 70% where we currently are. What's coming? Apps. More, as the app has shown me, how well patients adopt to it. Is it a whole lot better? It certainly functionally has a lot more promise. But these are things where we're going with testing these ideas, and all these things can be modified. We're now past the failure point to where it's more perfecting it. Compliance really came back to getting results same day, getting them scheduled for the annual scan, text reminders, communication through other means than humans to keep the process going. So there's way more than this that occurred. I'm happy if I have no financial stake in building the buses, partly because I didn't think it was going to succeed. But second was also to be objective so that we can really solve this problem together. It's going to continue. It won't be the same 8 years from now. It'll have a different role, a different mission, different look. But anybody interested, I'm happy to sit down with you, help build business plans, see if it fits, but go through that process or entertain you at our site. This is how to get in touch with me. Thank you.